Imagine you're asked to solve the traffic congestion problem of a tier 1 city where the average commute time has gone from 45 minutes to 75 minutes in just 4 years. The pollution has gone up and the citizens are angry. The chief minister wants you to solve this problem in an economically sound and politically feasible way. Hi everyone, welcome back to my channel Pathfinder with Yatnika. Today in this video, I'll be talking about how to solve public policy cases in detail. So let's get started. So before we start, let's look into the impact framework which we'll use while solving this case. First is issue definition. Ask what exactly is happening, where is it happening, and what is the magnitude. Without clarity here, everything else becomes noise. Next is multi stakeholder mapping. Public policy problems affect many players. Map out who are the citizens, government bodies, NGOs, private sector, wildlife or environmental authorities, etc. Each stakeholder has different incentives, different power, and different constraints. Then comes the problem drivers. Now diagnose the root cause. Break drivers into four buckets. Structural. Is it infrastructure gaps, urban design, or lack of systems? Behavioral problems related to habits, awareness, compliance. Economic. Is it incentives, pricing, affordability? And operational problems like execution failures, inefficiencies, etc. Next is alternatives. Now generate solutions. Typically, public policy levers fall into regulation, that is, setting rules or limits, incentivizing, like encouraging good behavior, investing to build infrastructure or capacity, educating, that is, creating awareness, or enforcing to ensure compliance. Next is the cost benefit prioritization. Not every solution is worth doing. You must evaluate each option on the impact per unit cost or effort, feasibility, and time to effect or see the results. Next is test and track. Finally, design how the policy will be rolled out. Ask, can we start with a pilot program? What are the KPIs to look into? And how will we monitor and measure success? This helps ensure that interventions are effective, measurable, and scalable. Now let's start solving the case. First, we'll start by understanding the scope of the problem. Is the congestion concentrated in a particular part of a city or is it citywide? Is it only in peak hours or is it all day? And what kind of a vehicle is causing this congestion? Is it cars or buses, etc.? Let's say the interviewer mentions the congestion is concentrated in the CBD corridors and mainly dominated by the car during the peak hours. Then we will understand the objectives. Is the primary goal of this project time reduction, pollution reduction, or political approval? And do we have any numeric targets here? The interviewer says the effects are mostly spiraling here, so all of them are mostly connected. So the objective is to reduce both time as well as pollution and enhance convenience for the citizens. Also, we do not have any numeric targets here. Let's understand the constraints now. Is there a budget size or political red lines? The interviewer mentions that the budget is moderate and the government can consider all policy levers, even the unpopular ones. Now let's understand the governance here. How is the control over police and transport distributed between the city and the state? The interviewer says the city government controls traffic, parking, and buses. State controls metro, taxation, and fuel pricing. Traffic police are under the state, but city can coordinate priorities. Let's apply the impact framework here. We'll start with the issue definition. When we observe the city closely, four things stand out. One, vehicle ownership is rising rapidly. Public transport has a very low share of daily travel. Last mile connectivity is poor, so even people who want to use buses or metro find it inconvenient. And lastly, there is no price signal for using roads. They're essentially free. This tells us something important. Congestion is not just an infrastructural problem, it's structural, behavioral, and institutional. That's why simply building more roads doesn't fix it. Next, let's look at the multi stakeholder map. Commuters want faster and cheaper travel, but they strongly resist tolls or congestion pricing. Low income groups depend heavily on buses, and they suffer the most when public transport quality is poor. Businesses care about reliable logistics and deliveries, but often oppose restrictions on vehicle movement. Politicians want to stay popular and fear voter backlash from unpopular policies. Traffic police are responsible for enforcement but face serious capacity and technology constraints. Urban planners think long term, but their designs are often overridden by political decisions. So, any real solution has to balance all these incentives and risk. You cannot optimize for one group and ignore the rest. Now, let's break down the problem drivers. Structurally, most cities are designed around private cars, not people. Public transport has historically been underfunded, which makes alternatives unattractive. Economically, roads are free to use, so they are overused, and parking is massively underpriced. When parking costs less than a cup of a coffee, driving will always feel like default choice. Behaviorally, people prefer private vehicles because they offer comfort, perceived safety, and social status. Even if public transport exists, people won't switch unless it clearly feels better. Operationally, traffic systems are inefficient. Signal timing is poor, enforcement is weak, and traffic management is often reactive instead of data driven. With that understanding, let's evaluate the alternatives. The first option is supply side expansion, more roads, flyovers, and metro lines. While this sounds intuitive, it's extremely expensive, slow to build, and often leads to induced demand, where more road capacity actually attracts more cars and restores congestion in the long run. The second option is demand management. This includes congestion pricing, parking reforms, and carpool incentives. These directly address overuse of roads, but they are politically sensitive and need careful design. The third option is encouraging a mode shift, improving buses, metro systems, cycling, and walking infrastructure. People will switch modes only when these options are clearly superior, not just available. The fourth option is operational efficiency. Smart traffic signals, better enforcement, and data driven routing can deliver quick wins at relatively low cost. The fifth option is land use reform. By promoting mixed use zoning, cities can reduce the need for long commutes altogether. The best trip is often the one you don't need to make. Now, let's compare these options on cost, impact, and feasibility. Congestion pricing has very high impact and low financial cost, but high political risk. Bus priority lanes deliver medium impact at low cost with relatively low backlash. Metro expansion has high impact but extremely high cost and long timelines. Smart signals and parking pricing offer medium impact at low cost and are easier to implement. Work from home incentives deliver medium impact at almost zero cost. So, the logical approach is to start with options that have high impact, low cost, and low political resistance. That brings us to testing and tracking. Instead of rolling everything out citywide, we should run pilots. For example, one congestion pricing corridor, a few bus priority lanes on major roads, and smart signals at key intersections. We then track clear KPIs, average commute time, traffic speeds, pollution levels, and public satisfaction. Public policy isn't about being perfect upfront, it is about learning quickly and scaling what works. Before concluding, there are a few important nuances worth mentioning. Building more roads create induced demand in the long run. Pricing mechanisms can hurt lower income commuters if not paired with better public transport. Congestion pricing is often technically the best solution, but politically the hardest. Institutional capacity, enforcement, and technology matters more than policy intent. And finally, behavioral inertia is strong. People won't change habits unless alternatives clearly outperform private vehicles. So, the final recommendation is that in the first phase, over the next 18 months, focus on quick wins that is, smart signals, stronger enforcement, bus lanes, parking pricing reform, and work from home incentives. In the second phase, over the next 18 to 36 months, introduce demand management through a pilot congestion pricing zone while expanding bus fleets and last mile connectivity. In the long term, over the 3 to 5 years, invest in metro expansion and land use reforms to structurally reduce the need for daily commuting. The key takeaway here is urban congestion is not a traffic problem, it's an incentive problem. And that is how you solve a public policy case. In the next video, I'll be picking up a case with an operational or logistical problem, so stay tuned for that. Please hit the like button if you found this video helpful and subscribe to my channel to stay updated. I'll see you in the next one.